Hiya! Let's learn how computers make decisions. Computers operate on a binary system, binary being two of something, so either an on or an off, or high amount of electricity, low amount of electricity, 1 or a 0. Any situation where you have two possible states, you have a binary system. You can then potentially have a computer. At their core, computers need to be able to change information. So as long as you can change a binary state from one to the other, you can create a computer. Here we have a mock-up of a transistor or a relay. They operate differently, but same core concept, which is there's an input, a decider, and an output. And this decider, if it's on, it allows the output to go through. If it's off, it prevents the output from going through. So here we have an input signal that's on, and we turn the decider to on, and the signal goes through. That is the most basic fundamental building block of all computing. Now we can use that to actually make decisions, and doing that happens through what are called logic gates. So here we have one of the most basic logic gates in existence, the AND gate. The way that an AND gate works is if one input and the other input are both ones, are both on, are both high electricity, are both, in one state, the same state, then the output is a 1. It's on, it's high. If either output or both outputs are low or off or 0, then the output is 0. So it only lets a signal through if both of them are on. And we can see that here. If we turn on one input, the output is still off. If we turn on the other input, the output is still off. But only if both inputs are on do we get a signal that goes through. And that right there is a logic gate. It makes a decision. It uses logic. So it says, if this and this, then true. So if one and the other, then true comes out. There's also the OR gate. If one or the other, or both, then we have true that comes through. We have the exclusive OR gate. If one or the other, but not both, it'll be true. So we only want it if one or the other. And we've got a simple NOT gate. And all this does is it inverts the signal. So it says if 0, if off, on. If true, then false. Just make it not what it was before. Hope to see you next time. Ciao.